Yes, sir.
Okay. So suppose first of all, I'm taking an example to digital design. So there is a question. So suppose in real life, uh, we have already seen that in a car, there is a functionality like suppose one person is put a seat belt and enter the key into the car, then LED is not glowing. But suppose you are entering a key into your car and you are not putting a seat belt, then LED is glowing or a siren will uh, create a noise, right? Like so. Suppose I want to make a digital circuit for this. Okay, so here how many inputs are there? Two inputs, right? One is key, one is key, and another input is belt. Okay, so output is depends on two inputs, key and belt. Okay, and what is our output? Suppose LED. Output is LED. Okay, so what will be the truth table? 0, key is not putted, so belt is putted or not, it's not mentioned, so output will be 0. If key is not putted, so doesn't matter belt is putted or not. Okay, so LED will be 0. Suppose key is putted and belt is not putted, so what should happen? Output should be 1, means LED should be glow, right? And if key is putted and belt is also putted, then output should be 0, right? So how do you make the circuit? Like this. So here, suppose we are doing in SOP form. So how do you do? Here is 1, right? Here is 1. So what is the inputs of in terms of this? Key is 1 and belt is 0, then output LED will be 1. So what will be the equation for this? Equation will be LED equal to key dot belt complement, right? Belt complement, right? So this should be equation. So you will design this circuit using by one NOT gate with belt and key, two inputs are there and ended with this, right? So like that it will be the equation. So in previously we can see that this is very small circuit, so you can design this circuit by using cell design, right? So in terms of backend, people doing this cell design work, right? So you can simply design the one NOT gate and another AND gate, and you can connect like this. Okay, but suppose you have a very big circuits, very complex circuit, so it will be the very difficult to design by using cell design, right? So there is only two gates, so you can design easily, right? Suppose there will be millions of gates, so how can you design, right? So it will be very difficult. So now for design the complex circuit, Verilog came into the picture. Verilog came into the picture. So what is the Verilog? Verilog is a hardware descriptive language. Hardware descriptive language. So by using this language, we can define the hardwares. This language is a high abstraction language. Okay. So now there are four types of modeling to design using Verilog. Four types of modeling, in the sense you can say that there are four types of style to design by the Verilog. Okay. So first is gate level modeling. Next, data flow modeling. Okay. And after data flow modeling, what will be the next? Next will be behavior modeling. Okay, and next is switch level modeling. Okay, so what is all types of modeling is there? Suppose you are doing design using gate level modeling, so you should have available a circuit in terms of gate level. Like that, I have already designed this circuit using gate level, right? So you should have need a circuit in gate forms, right? And this is also called as white box modeling or structural modeling. Okay, gate level is also called as white box modeling and structural modeling. Why structural modeling? Because we know the structure of this circuit, right? How is our structure of the circuit? Suppose in previous design we have a structure like one NOT gate connected with one NOT gate connected with belt. Okay, and key and output of NOT gate is connected with AND, right? So we know the architecture of this circuit. So we can see like what is the architecture? Sorry. Suppose this is our key and this is our belt. So here should be NOT gate with a belt and this should be AND gate, right? So this is a real-time example circuit, right? Real time. Suppose in a car there is a functionality. Someone if put it key and not put it seat belt, then LED should be glow. Okay. Please everyone mute yourself. Okay. So this is our circuit. So we know the circuits in gate form, right? That's why it's called structural modeling. We know the structure of this circuit. Same case in data flow modeling, we are work on operators. In behavior modeling, we don't have required of a structure of the circuits or systems which we are going to design. So we should know only behavior of this circuit only. Like suppose you are doing working on mod 10 counter. So what is the behavior of mod 10 counter? Behavior is counting from 0 to 9, right? So this is the behavior of mod counter. So we don't have required what is the circuits of mod 10 counter in using behavior modeling. Okay, and same in switch level modeling. Switch level modeling is also called as structural modeling. In switch level modeling, you have required circuit in terms of switch. Switch means MOS, CMOS, NMOS, PMOS, like that. Okay, guys. So how will you design by gate level modeling? First of all, I would like to take an example based on how will you design a circuit using gate level modeling. So what is the structure of coding? What is the structure of coding? So structure of coding is module. For every language there is a syntax, right? Suppose you are done C language, you have read C language, so there is a syntax like hash include studio.h, like that, right? So every programming language there is a syntax, particular syntax. So for Verilog there is a syntax like module is a keyword, and after that you have to provide module name. You have to provide module name. Okay, after that you have to provide port list. Here port list. So what is meaning of port list? And we are writing every code between the module and in the module. First of all, like in C language you are doing code like between the open the curly main functions like that, right? So here every code written in module and in module. So every components will be written between the module and in module. So now coming the module name. Module name means whatever you are doing. So you can keep anything in module name, right? Suppose you are doing a half header circuit. So you can keep name module half header, half underscore header. Okay. In port list, what things will come into the port list? The meaning of port list, like suppose you are designing any ICs. Suppose you are designing any IC. Suppose this IC, right? You are designing. So how it will looks like this, right? It will looks like this, right? So this is two input ports and this is our output ports. So it's called as port list, right? This is called as port list. But here suppose this NOT gate is connected with this AND gate input. NOT gate output is connected with NAND gate input. So it will not come into the port list because this is not a port of your IC, right? So suppose you are doing an example of half header. So what will be the all things will be come into the port list? Two inputs like A, B, and output sum and carry, right? So this is the structure. After that, you have to design, we have to do direction of the port. Here you have seen already. What is the direction of this port? So this is our input. This is also input. And this is our output. So you have to define the direction of your ports. So this can be only in case of some circuits, it can be in output also, right? So you have to define the direction by using input and signal name, all signal name, input and signals name, right? Semicolon. After that, output signals name, whatever your signal. Here in out signals name, okay? And after that, in gate level modeling, we have lots of gates are previously available, lots of primitives available we have already in tools. So what all primitives are available in gate level? And, or, not, XOR, and XNOR, NAND, NOR, buff. Buff means buffer. So these all types of primitives available in our libraries. So we can use these libraries to make any circuit. Okay. So here, next step is gate instantiation. Gate instantiation. Instantiation means calling, right? Instantiation means calling. So here we have to call the gates, right? Gate instantiation. So how do you do gate instantiation? So gate instantiation by gate name. After that, instantiate name. Like suppose you are doing a full adder circuit, right? So in full adder, there are two XOR gate, right? Two AND gates. So there is two XOR gates. So suppose you are calling two times your XOR gate, so it will be get confused like that, right? So for what XOR gates you are telling about, right? So you have to do here instantiation name, right? Instantiation name, instantiation name. Okay. And after that, After the instantiation name, what all things we have to do? Here, port list of your gates. So what will be the port list? First of all, you have to write the output. First of all, you have to write output, then inputs for every predefined gates. For every predefined gates, you have to work like that. Okay. And after that, semicolon. Okay. So this is our structure of this coding. So suppose we are doing like that, our half header design. So see here, how will you design your half header? So module, what is the module name? Half header, half underscore header. Okay. What will be the port list in half header? Two inputs, a comma b comma some comma carry, right? So this all things will be come into the port list. After that, in the module, between this, what all things we have to do? First of all, input signal name. So what is the input? Input is keyword. Signal name, what all signals we have in input? A comma b. Okay. Again, we have to put output. What all things we have output? Some comma carry. Okay. So there is no required of in output, right? So you don't have to mention this. Next step. What is our next step? So our next step is get instantiation. So in case of half header, what is the circuit of half header? So you can see easily what is the circuits of half header. See here, the circuit of half header is one XOR gate which has two inputs A and B, and sum is our output. Same case of AND gate, carry is your output and A and B is input, right? So how will you do? First of all, we are going to call XOR gate. So how will you call? Gate name, right? Get instantiation. How will we call get instantiation? How will you do? Get name, instantiate name. So get name will be compulsorily XOR because we have XOR functions predefined, right? So XOR. After that, you have to write instantiate name. So what will be the instantiate name? You can give here anything in instantiate name for your understanding, right? So you are putting a name of this gate, right? So here, suppose we are providing here G1. And what things will come now? After instantiation, output comma input. So what is the output? First of all, we have to write output. So what is your output of XOR gate? What is output of XOR gate? Sum. In circuit you have seen already. So for half header, sum is output of XOR gate. And after that, what is the inputs of XOR gate? A comma B. Okay. So next statement, we need to call one another gates, which is AND gate. Again, you have to provide instantiation name G2, right? What is the output of this? Carry, comma A comma B, two inputs A B, right? Two inputs A B, right? So this is our half header circuit. This is our half header circuit design. So you can see here, suppose we are doing this on a tool, so it will generate a half header. Sorry, wait for a minute. Basically, we are going to open a tools. Creating here half header. Here we are pasting this same code which we have written, right? And going to simulate this. Okay, in module. Sorry, it's taking some much time. Now check syntax. Somewhere is syntax error. Half header AB, some carry AB, some comma carry, and some comma. So there is no syntax error. Yeah, so now it's generated. You can see here, this is a schematic of half header. So there is two input A, B and carry and sum is output. Now you can open is this like this. So here A and B are two inputs, sum and carry is output, some output from the XOR gate, right? This is our XOR gate. So output of sum is came from the XOR gate and output of carry is came from the AND gate. So this is generated your half header. Okay guys. So now can we move forward? So here we have designed half header, and after that suppose you want to do the verification of half header, right? Here we have done verification of half header circuits. So now we are going to do the verification of half header circuit. So first of all, doing the verification, we have to read something like about data types in Verilog. Some data types in Verilog. data type. Sorry guys, please mute yourself. So data type is reg data type. Sorry, data type. Okay, so one is reg data type, another is wire data type. Wire. So time being, we'll explain more data types also, but here you need to know about the reg and wire. Okay, so what is reg and what is wire, right? Suppose you are writing here input and output. So what is meaning of input and output? So all inputs and output by default wire data type. All inputs and outputs by default wire data type. Okay, so what is the, sorry guys, can you mute yourself?
Sir, you can remove if they are creating.
Yeah, so reg and wire is two data types. So what is reg and what is wire? So reg means it can store a bit. Okay, wire can't store any bits, can't store any bit, right? So you can assume simply wire. So what is meaning of simple wire? So in real life you have seen this is wire like this. This is a wire. So what is meaning of this wire? If you will connect something storage energy with this, then you will get here current, right? Then you will get here current. Otherwise you will not get current here. Means you need to continuously connected with this, right? Whenever you will not connect with this, then disconnect with this battery, then what will happen? You will not get here output, right? So no, you will not get here current, right? So wire is not a storage type, right? You can only drive the value on wire, means continuous till the time you will get here value whenever you are driving continuously, right? In case of reg, so reg is like a storage things. This is a storage things. Like you can see that you have read already capacitor, about capacitor or battery, anything. So this is a storage the energy, right? This has a storage the energy. So this is has some value is a storage. Suppose here you have stored the 1. So once you will store here 1, so you will get value every time. You don't need to again and again, means continuously store the value, right? So till the time it will store 1, when you will not get another value here, not put another value here, right? Suppose you are putting here another value, so instead of 1, another value will come here. Okay, in case of reg, so reg is storage things, right? But in case of wire, what will happen? You have to change the storage things, right? You have to change the storage things, then only you will be able to change the value on wire, right? Otherwise you can't drive. Like suppose you are driving directly some value 1 on wire, right? So you can't change another value. So first of all you have to use any storage things, a storage data type for this, for change again and again the value of wire. Yeah, so I was explaining about reg and wire. So reg is a storage things and wire is not a storage things, right? So now coming to the test bench. What is the test bench? Basically using test bench we are verifying the functionality of a design, right? So as per the design we have different types of test bench. So what is the rules of test bench? So you have to make an architecture of test bench like this. This is, suppose we are going to make an architecture of test bench for half header, right? So what will be the architecture of this test bench? There should be two input like this and two outputs here, right? Like this architecture should come. And after that, what should happen? After that, here we have to call the design. Under this, we have to call the design. So under this test bench, we have to call the design. And after that, how is your design? So your design is like this. Your design is like this. Your design has two input and two output, right? Yes. So what is the need of this? Now we have to connect this signal to this signal, means this input to this input, means verification test bench input to the design input. We are going to connect like this, right? Here input to input and output to output. We'll connect like this. And what is the next step? So next step is, here we need to provide the some inputs from the test bench, and this input through the wire come to here, and this will come to here, okay? And design will generate some output and provide some output, so you will observe here, okay? So same output you will observe here. So how will you do? Same thing like that. Now see here. So this should be your storage type, right? Then only you will be able to change the signal, right? This should be a storage type, then only you will be able to change your signals, right? Okay, so can you check for your internet connection? Contact ready? Yeah. So here, what is here should be a storage things. Then only you will be able to change the value of this, right? Otherwise, you will be not able to change the value. Suppose you are assigning a value continuously connected with wire, right? Will continuously connect with wire, with anything will connect with wire. So what should happen here? What will happen here? So you will not able to change these things, right? Because you have connected continuously. So what will you do? Suppose you have taken a storage things here, right? You have taken a storage things, and I will change the value of this storage. So automatically it is connected with wire. So for the test bench input, what should you have to take? Reg. Reg is a storage. That's why you have to take here reg data type for input purpose. And here we don't have required of storage things, right? We don't have required of storage things, because this design will convert anything and you will get here and observe here, right? So here from the storage, it will get input, design will get input, and after that it will produce an output, and you can observe here output. So we don't need to store these things, right? So what will you use? Wire. For test bench purpose, you have to use wire. Okay. So now see here, how do you write your test bench? Your test bench can be written like this, same module and module name, again module name. So we can keep anything in module name, tv underscore half header ha, okay, module name. There is no requirement of port list. Why not required of the port list? Because we are not going to create any types of chip or IC, right? just we are going to verify this IC, right? We are not going to create any hardware by using test bench. This is only for the verification purpose. So here you don't have to provide port list, right? Again, same things in module we come, and here for input purpose, what will you take? Reg data type. So reg a comma b, okay, wire sum comma carry. So now one another things, instead of a b or sum carry, you can take another name also. You can take any name like this, same you have seen in diagram, right? You already seen in diagram, you already seen have diagram. This is another wire and this is another wire, right? This is another red color wire is for design and black color is for test bench. So both are different wire. Just this wire is connected with this wire, means test bench wire connected with design wire. So this wire name can be different and this wire can be named can be different. So anything you can put anything name in anything, right? So just we have put it here what? AB, sum and carry. What another things? You have to call the design. You have seen already, right? Already you have seen here what you have done. Call the design between the test bench, right? So call the design. And after that, how will you call the design? So like this. What is this? Half adder, A, B, sum, carry, right? So in positional mapping, we'll tell you again later what is name mapping and positional mapping. So you can connect with these things using name mapping or positional mapping. Okay. So here you have instantiated XOR gate, AND gate. This is predefined gates, right? But half adder is user defined. We have defined already. So module names should be same to call this. So what is our module name? Half adder, half underscore adder. Okay. Again, instantiate name. So you can keep anything in instantiate name. Okay. So we have keep here half adder, HA. Again, port list. So in case of predefined gates, it is mandatory to write that output is first and after that input. But in case of user defined primitives, what will you do? You have to see these things, how your port list is declared. So whatever you are writing at first position here, so it will directly connected with A. Whatever you are writing second position, at second position, it will connected with B. Whatever you are writing at third position, it will connected with sum, right? So suppose you are writing here A comma B comma sum comma carry, right? So at first position we have written A, second position B, third position sum, and fourth position carry, right? Suppose you have mentioned here instead of AB, you have mentioned here XY or PQ. So you have to write here P, and instead of B you have to write here Q. So P will automatically connected with what? A in design, right everyone? So now third step is to provide the inputs. What is the third step? Provide the input, right? So how will you provide the input? So there is a block in Verilog. So there is a block named as initial block. So in C language you are using main function. So in Verilog there is initial block, same like that, right? And instead of curly braces, opening or closing the curly braces, you have to write here begin and end. So every time in another coding language you are using curly braces open and close. So here instead of all the curly braces open and close, you have to write here begin and end. Okay. For the people who have not done any coding language, so for them I am telling you, this is an initial block, means this is a block. Whatever sentence you are writing here, it will come into the this block, right? Suppose you are not writing begin and here, so what will happen? suppose you have written here 3 statements, so only first statement will consider as in initial block, the rest statement will not consider in initial block. Okay, so now here we have to provide the inputs. What inputs we are providing? A equal to 0. Okay, semicolon means statement is terminated, means line is terminated. Doesn't mean that if you are writing here b equal to 0, so doesn't mean it is a single line. This is two different line, because you have here mentioned semicolon. So after semicolon, if you are writing all codes in single line, it doesn't matter. Okay, again we are writing here what? A equal to 0 and b equal to 1, like that. Again we are giving input a equal to 1, b equal to 0. Again we are writing here a equal to 1 and b equal to 0. So what? This all combinations for half adder, right? Half adder inputs. This all combination for half adder input. But there is a one problem. Suppose you are providing these inputs at same time means at 0 time, like at same time. So what will happen here? So output will be changed immediately. So you will not get time to observe your output, right? You will be not able to observe your outputs. That's why what should you do? After 0 time, you have to provide here some delay. For next input, you have to provide here some delay. So how will you provide delay in Verilog? By using hash keyword. Suppose you are providing here 5 time unit delay of between this and this. Again 5 time unit delay between this and this. Again 5 time unit delay between this and this. Okay, so if you are getting 5 time unit delay, so what will happen? At 0 time you will get a equal to 0 and b equal to 0. So sum will become here 0 and carry will also become 0. At same time a equal to 0 and b equal to 1. So what will happen here? Sum will become 1, carry will become 0, like that. Okay guys, so this is our test bench for that. So I'm copying this, and in test bench part we are writing like this. Okay, just here I'm providing. Here we have provided like same code here pasted here, right? Reg a b sum carry, this is our half adder instantiation, and we have provided all inputs. Okay, so now we are going to observe the waveform here. So see here what is happening. At 0 time we have provided input 0 and 0, a and b 0, then output can sum 0 and carry 0, right? Again at 5 time you have provided here a equal to 0, b equal to 1. So in graph also you can see, and here the value mentioned. At 5 time what are you getting? Sum equal to 1 and carry equal to 0. And after that this time same value is maintaining because you have not changed. So at 10 time you have again changed your inputs, right? At 10 time you have changed your input. So what will become here? A equal to 1, B equal to 0. So output is sum 1 and carry 0. And after the 15 times, what will come here? Sorry, we have no change. 1 1. Whoa, sorry. Just we need to provide here 1 1, right? 1 1. Then only you will get value for this also. So what is happening here? After the 10 time you are getting 1 1. So carry is 1 and sum is 0. Okay, guys. So this is all about half header, coding and test bench. So now we are going to define, tell you about something about the different types of values in Verilog. So what all values in Verilog? Values in Verilog. So different types of values in Verilog. In Verilog. So what all different types of values in Verilog? So Verilog is worked on four types of value: 1, 0, X, and Z. So what is the meaning of 1, 0, and X and Z? You already read in digital. 1 means high voltage. 0 means low. X means unknown. Unknown means he don't know 1 or 0. He don't know 1 or 0. Can be anything. Means what is this? Unknown means what is this? Don't know 1 or 0. So you have read in Verilog like about don't care, right? So don't care is X. And Z. What is Z? Z means lie, right? High impedance. High impedance means unconnected. Yeah, not connected with anything, right? It means high impedance, right? So same things you have read here, reg data type. So what is meaning of reg data type? So reg data type will store always some values. So value will be what? By default value of this, X, right? Default value will be X here, right? Same in case of wire data type. What will be the default value? It is not a storage type. If you are connecting something with this, then you will get this value, right? So suppose you have not connected with anything with wire. So by default value will be wire, right? We have not connected with anything, then default value will be wire. Good, right? So guys, do you have any questions till now? Actually, we are going to bind up for today. So if you have any questions in your mind, you can ask.
Like in the test module, right?
Yeah.
Hello.
Yeah, hello.
In the test module, you have mentioned that our input will be register and output will be wire, right?
Right.
What I will be having in between of my test bench and module?
Pardon, please.
Like, could you please open the diagram like of the
Sure.
test bench and module?
Sure. Yeah.
Yeah, over here you have mentioned me up like in the input I will be having register and output I will be having wire. what I
Right,
will
right.
be having between this test and test bench and module, like in between of them.
In between of them, test bench and module. So see
Yeah.
here, uh, you have taken here in design, you have design taken here input, right? This signal is your input signal, right? In design.
Yes.
Yeah, this signal is also input signal. This is your output signal in
Oh,
design. So by default, all inputs and outputs are wired data type. Suppose you are writing input and output, so by default it is wired data type. So this is wired type. That's why we have
okay.
connected this with a reg data type with a storage things, right? Because we can
Mm-hmm.
change this value anytime, at any time, right?
Mm-hmm.
So whatever you will change here in a storage type, so same thing you will get in wire, right? Suppose your storage type is here, you can take example of a battery. Suppose your 5-volt battery, so obviously you will get here 5-volt, right, in wire. Suppose you have changed this by 10-volt, so how much you will get here? 10-volt in wire,
10 volt.
right?
Definitely.
Yeah. Now any other question anyone have? Anyone have another question? Any another question?
Is wire doesn't store any value?
Yeah, wire can't store any value. Wire is simple a wire,
Why,
like
sir?
in real life we have seen wire, right? In real life, just compared with your real life, wire, what is meaning of wire in real life? Same thing in Verilog also.
Then why it should be high impedance, sir?
Yeah, high impedance means
Simply it
unconnected.
should be zero, right, sir?
What? No, high impedance means unconnected. High impedance means not connected with anything, means not any value, right?
If wire is not connected, then it is called
Impedance means, sir?
High impedance means unconnected, not connected with anything, right? It means not connected with anything.
like if the wire is not connected to the device, then it is called
Yeah, so by default value is, that's why
Z.
Z. Yeah, means not connected. If you will connect with anything, then you will get some value. Suppose you have connected with reg and you have not put any value in reg, right? Then you will get X here, because reg by default value is X, so same value will drive here. Anyone else?
Sir,
Yeah, please.
the test bench is called verification.
Yeah, test bench is right for written for verification purpose, for functional verification, right?
Okay, sir.
Means you are checking the functionality of design is correct or not. You know, like lots of time in complex circuit, just we are taking an example of a mobile, right? Taking example of your mobile. So in coding purpose, they can change anything. Suppose one time mobile motherboard has been mad, means hardware is created, so you will be not able to change any functionalities, right? Am I right? Who has asked this question? Hello?
Sir.
Yeah,
Can be.
so you will not able to change the functionality of this ICs, right? So what so suppose suppose you have designed a mobile and hardware has created and there is a bug in your circuit. Suppose you are doing a flight mode in your mobile, so whenever you have done flight mode, so after that also in your mobile network is coming, so it means what? This is a bug, so you will complain to the company, right? So company will, what will do? They will do, so lots of chip they have manufactured already, so they will be get wasted. And also another things what will happen, so in market uh, actually they will destroy his them market value, right? So that's why they are focusing more on verification things, functionality verification by coding, right? If you have done coding functional verification by coding, so suppose you will find any bug. Suppose instead of 1 1, we have in half header we have done like 1 1, two inputs 1 1, so you are getting here sum is 1 and carry is 0, so it is wrong, right, Arpit? So this is wrong. Hello? Love Krishna, right? It was your question, na? So you can change easily your code again, right? But if you will create a hardware once, right? So you will not be able to change. So your company will go into the loss. That's why we are writing test bench for functionality verification, functional verification. Is it okay for you?
Okay, sir. Okay, sir. Okay, sir. Okay. Thank you,
Yeah.
sir.
Yeah. Anyone other? Anyone has another question? So can we bind up for today?
Yes, sir. You can end up the meeting.
Yeah. Thank you.
For registrations, you can WhatsApp. Guys, for registrations, you can WhatsApp. Contact me on WhatsApp. Okay, end up the meeting. Thank you, sir.
Thank you. Thank you, guys.
Thank you, sir.
Thank you.